Hello everyone. So in this video, I'll be talking about a project I was working on lately. It's called Information Retrieval System, and what it does is that given a user input, it gives you the top three suggestions to the input that you gave, and those suggestions are from basically a database that has around 1 million questions, and it gives you the top three suggestions in about less than a second. And the front end that you see is basically designed using HTML and CSS, and the website server is basically the I'm using Flask for that. Now, how do you get the suggestions? Now, for that, I am using deep neural networks, and Siamese based LSTM is the architecture that I deploy. And the best part is that I'm running this model without any GPU, so it's currently running on my CPU, and it doesn't need a GPU to to test at the inference time. So let's quickly see, give an input and see the kind of results it gives. So let's say which laptop is good for programming. Oops. So it says what is a good laptop for programming, what is the best programming laptop, what is the best programming laptop, and you can see the time required for the search space was just 0.3 seconds. So it's 1/3 of a second. I think it worked pretty well. So another thing is that basically, let's say if these words are not present in my vocabulary, so people who are aware about NLP, they know what a vocabulary is. So in that case, let's say something that is not present in my vocabulary, let's say a full stop, maybe that is considered as a stop word. So in that case, even though this is not a very important part of the project, but just to show you guys, so in that case it will come back to its original page. But let's say let's put who is Modi. So let's see what it gives. So it says, how is Modi doing? How is Modi doing? Is Modi overrated? Uh, anything else we can put, maybe? How do I find peace? How I find myself? What are negative sides of Twitter? How can I find what my IQ is? So maybe there is no matching word peace present in the database, and it gives you something what probably will tell you the negative sides of Twitter. So if you get rid of that, you might find peace. So not bad. So basically, this is how it works, and at behind the scene, basically I'm using a Siamese based LSTM, so to say. Basically, this is the network. It has three functions. First function is the embedding function, second is the middle function, and third is the predict function. So the data set has, as I told you, 1 million questions. Each column has around 5 lakh questions. That's half a million. So the task is not to basically tell whether they are similar or dissimilar, but to finally put in a query which can give me the closest matching pair out of those total 1 million questions. So here, if you see, this time is very less. So if I use a brute force method, it takes me around more than 4 or 5 seconds to get this result. Whereas using some clustering based method, I can achieve the same results. The results, you will get the same results if you use brute force. I had tested that. So if you get that in less than a second, so which I think is quite good. So basically, this embedding function takes in these questions as an input, as an integer, and then maps them to a 300 dimensional vector. It converts into a vector, each word, and then that word goes to this middle function on which I apply a max pooling layer. Now this max pooling layer, why I use it is because I try to extract the important features from that sentence which is inputted to the model. On top of that, I use LSTM. Fortunately for me, this kind of architecture, especially this function, basically this is what I tweaked mainly, helped me in increasing my overall accuracy. So this, on top of that, I apply LSTM, since I think applying LSTM on sequential data or like text data helps a lot. Though nowadays people are also using convolution 1Ds. So on this, I apply then dense layer. Why? There are like two reasons why I do that. First is, since it's a classification task, I essentially basically use it as a classifier, this network. And I'll tell you after that how do I get the features, because my task is not to classify at the end. So first is, since I want to classify, I use a 128 feature map which I pass into this predict function on this. So each time I'll pass two inputs. My Siamese network takes two inputs, question 1, question 2. So I'll get to, basically each function will be called twice. So Siamese network, I should have told this earlier. So Siamese network basically is nothing but a single network. As you have physically, it's a single network, but then you virtually can imagine two different parallel networks running. um, it's basically sharing the weights. So weights at the end are same for both the questions that you have. So this will give me two outputs for each of the question. On top, on those two outputs feature maps, I apply a L1 distance. Now this will give me some distance. Let's say two similar features will have a L1 distance, minimum L1 distance. Similarly, a dissimilar might have a L1 distance which is quite big compared to the similar ones. On that, I apply a dense layer which finally gives me outputs one value. On this dense layer, I use a functions activation function sigmoid, and then finally I have the label for that. So if this is what happens while I'm training, and testing is false, as you can see. But at the testing time, since I don't want to classify, but I want to take out the features, so I just keep just make this network basically at the testing time true, and I create a new network. And this whole network, this part I don't need anymore. So I just basically create a new network, upload the weights to these layers, and then get the features. Now another thing is, you might notice here I'm giving one input, but what about my network, since I told you takes two inputs? Well, as I told you, that Siamese network is a shared network. It takes the weights are similar, just shared weights. So I can get rid of the multiple layers. I just need these layers, one, two, three, four layers, just the four layers I need. So I just upload the weights into these four layers, which take, instead of one input, but takes sorry, instead of two inputs, it takes one input. So that way I can easily basically get, each time passing a question, I can get the features. So on that feature, then I compute Euclidean distance, comparing the questions that are present in the database, and I get the closest as the output. So this is pretty much about what my algorithm does. And you can see that for a start, I think the results are quite motivating. And I would love to take some suggestions from you guys on how I can improve the system, or how can I make the accuracy better. Currently I'm getting around 81 to 82% validation accuracy. I read couple of papers, so people have achieved like 87, 88%. Maybe using some ensemble methods, I think so. So yeah, so this is pretty much about it. And do let me know, leave your comments below, or if you like the video, then don't forget to press the like button. Thank you so much.